Hello and welcome back to another Math 112 video lecture. Today we're going to talk about some more identities. Yes, I know, more things to memorize. These are all on that reference sheet that I've told you about before. That's on to which I've posted the link on your Canvas. There are a couple out there, a couple of reference sheets that might be useful for you. Again, I recommend you use reference sheets only until you memorize the identities, but you do need to memorize these identities, and I know that that is obnoxious and hard, and just do the best you can. So let's get right into these, and I'll present these double angle formulas, and then we'll do a couple of examples. So the double angle formulas allow us to take something like the sine of 2 theta and rewrite that as 2 sine theta cosine theta. There are 3 different forms for the cosine double angle formula. Just memorize one of them. Pick one and memorize it, because you can get to all of these others from the Pythagorean theorem or the Pythagorean identity. If memorization is easy, then memorize all 3 of them. Notice I did not give you a double angle formula for tangent. That's because the tangent is just the sine divided by the cosine, so we'll find that as we need it. Okay, so let's work an example. Let's find, so we're given that the sine of an angle is 3/5. And we want to find the sine of twice that angle. So the sine of 2x, apply our double angle formula, is 2 sine x cosine x. Now we're not given cosine, but if we've got sine, we can get to cosine, because you remember that the cosine squared of an angle plus the sine squared of that angle is equal to 1. That means that the cosine of an angle is going to be equal to, we only need the principal root, so we'll just take the positive square root of 1 minus sine squared. We know that the sine is 3/5, so it's going to be the square root of 1 minus 3/5 squared, which is going to be 9/25. We can do a little bit of arithmetic and get to the fact that that is 4/5. So I'm just going to note up here that the cosine of x is 4/5, because we just found that. So now we can just plug in what we know. 2 times the sine, which is 3/5, times the cosine, which is 4/5. So that's going to be 2 times 3 times 4 is 24. Over 5 times 5 is 25, and the sine of twice this angle is 24/25. Okay, let me erase some stuff, and we will find the cosine of twice this angle. I'll just go ahead and write up here that that was 24/25. All right, cosine of twice this angle. Again, you can use any of the double angle formulas for cosine that suit your fancy. For this particular one, I'm going to use 1 minus 2 times the sine squared. And so it's going to be 1 minus 2 times 3/5 squared. We can do a little arithmetic, use our calculators, and we get to 7/25. So the cosine of twice this angle is 7/25. Now tangent's pretty simple. Tangent of 2x is just going to be the sine of 2x divided by the cosine of 2x, which is 24/25 divided by 7/25, or 24/7. Not so bad if you know your cosine and sine double angle formulas. Okay. This one also isn't nearly as bad as it looks. We're going to simplify the sine of 2x divided by 1 minus cosine squared 2x. And the first thing I'm going to do is take that denominator and replace it. We know that this is actually, sine squared of x. And we know that sine 2x can be written as 2 sine x cosine x. So our expression here is equal to 2 sine x cosine x divided by sine squared x. Oh, that's nice. This sine cancels one of those. We've got 2 cosine x over sine x. Which is equal to, which one? What is that? Yeah, that's cotangent. Tangent is sine over cosine. Cotangent is cosine over sine. So this thing simplifies to 2 cotangent x. All right, not so bad. Okay, so let's solve an equation. Let's suppose we've got the equation sine 2x equals sine x. First thing we're going to do is rewrite the left-hand side as 2 sine x cosine x equals sine x. Now, be careful here. You may be tempted to divide through by sine x, which you technically can do, but you have to handle the special case where sine of x equals 0 separately. So instead, what we want to do is subtract sine x from both sides. That means we now have 2 sine x cosine x minus sine x equals 0. Factor out our sine x. And we get to the sine of x equals 0, or 2 cosine x minus 1 equals 0, which means cosine x equals 1/2. So going around our unit circle, x is 0 or pi, or pi over 6, or 11 pi over 6. All right, now we've got double angle formulas. Stands to reason we've also got half angle formulas, and they look like this. The sine of half of an angle is equal to, now we have to take both the positive and the negative, square roots of 1 minus the cosine of that angle divided by 2. The cosine is the same thing except we add. And then tangent again is the sine divided by the cosine. Okay, this can be useful. Suppose we need to know the cosine of 22.5 degrees and we want the exact mathematical value and not the calculator answer. We're going to play a little game here. We're going to realize that 22.5 degrees is 45 degrees divided by 2. So that should mean that the cosine of 22.5 degrees is equal to the cosine of 45 degrees over 2. We can apply the half angle formula and get to the positive and negative square root of 1 plus the cosine of 45 degrees over 2. And from here, all we're doing is playing games with numbers in order to get this into a somewhat not ugly form. So let's do this. We've got the positive and negative square root of, just to make things, well, okay, we'll leave it like this. 1 plus, okay, the square root, or the cosine of 45 is actually root 2 over 2. Okay, that's not very pretty, but there's not a whole lot I can do with it, other than if I combine the numerator together, and I'm going to pull out that 1/2 for just a minute. So I'm going to write this as 1/2 times. This 1 is actually 2 over 2, so I've got 2 over 2 plus root 2 over 2, which means what I really have here is the positive and negative square roots of 2 plus root 2 over 4. I can at least get the fraction out of the radical and just have square root 2 plus square root 2 over the square root of 4 is 2, positive and negative. And there we go. That is the exact mathematical value of the cosine of 22.5 degrees, which I do realize that only math nerds are going to care about, because in the real world, if you were actually needing that value, you plug it into your calculator, right? Yeah, I know. But it's a fun little game. Okay, let's, again, apply our half-angle formulas. We know that the sine of x is 1/3. And we're going to find the sine of half of that angle, the cosine of half of that angle, and the tangent of half of that angle. So we're given sine x equals 1/3. We want to find the sine of half of that angle. And we know that that is a positive and negative square root of 1 minus the cosine of that angle over 2. Again, we're going to use the Pythagorean identity, the one that says that the sine squared plus the cosine squared equals 1. So we know that cosine of x is going to equal the square root of 1 minus the sine squared, which is 1/3 squared, which turns out to be 2 square root 2 over 3 when you do your arithmetic. So my sine of half of this angle is going to be equal to the positive and negative square root of 1 minus 2 square root 2 over 3, all divided by 2. Which simplifies to not anything really pretty. It simplifies to positive and negative square root of 3 minus 2 square root 2 all over 6. That is the sine of half of that angle. The cosine of half of that angle is the positive and negative square root of 1 plus cosine x over 2, which is the positive and negative square root of 1 plus 2 square root 2 over 3 divided by 2, which means that the cosine of half of my angle is the positive or negative square root of 3 plus 2 square root 2 all over 6. Okay, now tangent, again, is sine divided by cosine, so that's going to be the positive and negative square root of 1, whoops, sorry, not 1. Three minus 2 square root 2 all over 3 plus square root 2. Okay, now if you think back to when we did the radical simplification in math, 95? We probably did some in 111 too. You should recognize that there might be some magic happen here. Turns out there is if you multiply through first by on the bottom inside here, multiply by 3 plus 2 square root 2 over 3 plus 2 square root 2. So you do that first. Take the square root of what you end up with, and what you end up with is positive and negative 1 over 3 plus 2 square root 2. And now we do a little bit of work to rationalize this denominator. And what we get back to is that the tangent of x over 2 is equal to the positive and negative of 3 minus 2 square root 2. I'm going to leave this algebra to you. I'm not going to tie up everybody's time, but if you have trouble with this, let me know and ask the question either in email or in a study session. Okay, we are almost done. Just one more set of identities I want to go through with you. These are the power reduction identities. And these are really ways to take the sine of squared and write it as cosine. Now, you can develop these from a combination of a variety of the identities that we have worked so far. So these aren't necessarily ones that you have to memorize, and for that matter, the double angle formulas don't particularly have to be memorized either, because you can get to those from the sum identities, the sum of angle identities. The half angle formulas are a little bit harder to develop, so you probably want to memorize those. So let's rewrite sine to the fourth of x as sine of bx plus cosine bx. So start with the realization that the sine to the fourth of x is sine squared x squared. So let's start by applying a power reduction formula. Sine squared of x is 1 minus cosine 2x over 2, and that's squared because of the external squared. Square this and we get 1 minus 2 cosine 2x plus cosine squared 2x divided by 2. Now we're going to apply the power reduction formula to cosine here, and we get 1 minus 2 cosine 2x plus, and I'm going to do, so this is going to be 1 plus cosine 2x over 2. Whoops, not 2x, sorry, that's a 4. Because we've got a 2x inside and it's 2 times whatever is inside. So all over 2. So I'm going to do a little work here to make this a little prettier. We've got 1/2 minus cosine of 2x plus 1/4 plus 1/4 cosine 4x. Okay, let's pull these together. And we're going to have 2/4 plus 1/4, that's 3/4, minus cosine 2x plus cosine 4x. You get the idea. Just apply these identities. There's an example just like this one in your textbook. I'm going to leave this here with you, and in the next video we will talk about the remaining chapter of section 7, the remaining section of chapter 7, which is modeling changing amplitude and midline, and that's actually a much more interesting section. We're going to take a break from identities for a little bit, so I will talk to you all soon. Have a great day and do good math.